Welcome. Silent stripper and tail trimmer functions. The silent stripper function removes silent sections located at the beginning and/or the end of a sample. The tail trimmer function removes unused audio data located after the loop endpoint of a sample. As mentioned in previous videos, both functions can be launched from multiple locations throughout the application. To keep this video reasonably short, I'll demonstrate each available location without going into unnecessary repetition. The first location is the main application menu, accessible through the arrow button above the pack list. Let's start with tail trimmer. Depending on where the function is launched from, the scan results window will display different contextual information. Since we're currently scanning all installed packs, the results include details such as the pack name, voice name, element number, and the MIDI note range assigned to the affected sample within YEM. Before continuing, there is one very important detail worth mentioning. During the scanning process, the application verifies that a sample containing a removable tail is not being used elsewhere in the same pack with the one-shot option enabled. This option is part of Yamaha's voice configuration system and overrides the sample's loop settings. In other words, when one shot is enabled, the audio located after the loop endpoint may still be required and therefore must not be removed. For this reason, the application performs additional safety checks before presenting a sample as eligible for trimming. Once the message scan completed appears, the Trim Tails button becomes active and the trimming process can begin. In the lower left corner of the screen, you'll see the total amount of storage space occupied by unused audio data, along with the number of files that can be optimized. The amount of recoverable space is also calculated and displayed individually for each sample. From the same menu, you'll also find the Strip Silence function. Let's launch it. The scan window opens and starts analyzing all samples within the selected scope. In this example, a warning message appears. This happens because the critical threshold values used to detect leading and trailing silence have not yet been configured in the application's audio settings page. Let's open the settings window and navigate to the audio tab. We'll now set a value for lead silence and another for tail silence. With these thresholds configured, the silent stripper function can begin detecting silent regions within the samples. Let's run again Strip Silence function. A quick note, after recording this video, I added sorting support for both value columns, making the list much easier to navigate. This feature is not available in the version shown here. Both functions can also be launched for a single pack. Simply select the desired pack, open its menu, and choose the function you want to run. The displayed information is identical, with the only difference being that the subtitle now shows the name of the pack currently being scanned. To better demonstrate the tail trimmer function, let's locate a sample with a relatively large tail section. This will make the optimization process much easier to visualize. We found a sample with a fairly large amount of unused audio data after the loop endpoint. Let's see what it looks like. We'll locate the corresponding voice inside the pack. As a side note, I plan to add a search function in a future release to make locating contents in pack much easier. Now let's open the voice and navigate to the note associated with the sample we just found. Take a look at that waveform. Almost half of the sample consists of audio data that will never be played while the loop is active. It occupies storage space without providing any benefit. That space could be used for additional samples instead. Let's listen to it for a moment. As you can hear, the sample sounds perfectly fine. The loop points are correctly configured, and the audio data after the loop end point serves no purpose. This makes it a perfect candidate for trimming. The voice viewer screen also contains the final locations where both functions can be accessed. This is useful when you only want to process a specific voice rather than an entire pack. The first location is the voice viewer menu itself, accessed through the arrow button above the element list. Let's launch Tail Trimmer. The scan window opens and analyzes all elements contained within the current voice. The same applies to Silence Stripper. Both functions are also available at element level. As expected, only the selected element is scanned. Let's run Tail Trimmer first. And now Silence Stripper. Perfect. The same workflow applies to any other element within the voice. As a small update since the previous videos, I've improved the element control displayed in Voice Viewer. Even inactive elements can now be removed individually when needed, rather than requiring the use of the global delete all empty elements function from the main menu. Finally, the last location where these functions can be accessed is directly from the waveform display. Simply right-click the waveform. If both silence regions and removable tails are detected, all available options will be displayed. Otherwise, only the actions relevant to the selected sample will appear. Depending on the sample, this may include tail trimming, leading silence removal, trailing silence removal, or any combination of those operations. The same functions are available in the drums viewer screen as well, so there is no need to demonstrate them separately in this video. I hope you enjoyed this presentation of the Silence Stripper and Tail Trimmer functions, and that they help you recover valuable storage space currently occupied by what we could call sample programming mistakes. In the next video, I'll present the powerful Multi-YEM Manager feature, along with the content export and user data backup functions. If you found this video helpful, please don't forget to like, share, and subscribe. Thank you for watching.